Okay. This is the warm-up. All right. So for this unit, it's all about polynomials. It's these big terms, these really big expressions, where you have to add them, subtract them, and multiply them. All right. So number one, look at number one. What are the like terms for number one? 2x and 4x. If I have 2x's, I add 4x's to it. How many? So I'm not adding, I'm subtracting. If I have 2x's, I take 4 away. How many are left? Negative 2x's. So I have equals negative 2x. So mark out your x terms. What's next? So what is it? Positive y plus 2. Easy stuff. Look at number 2. What are my like terms? What are my first set of like terms? So 1x, then what? Plus 8x's is how many x's? 9x's. How easy is this? Super easy. Mark your terms out. What's left? So negative 5 plus 3. What do you get? Negative 2. Is anybody confused about the process? What are the like terms? I'm not entertaining you. Next, I have 2m's minus 4m's, negative 2m's. Those go away. Then I'm left with plus 5x, and then positive 3. You cannot combine these two terms. Those are different terms. Is that understandable for everybody? The variable's different. You cannot combine them. Look at number 4. What do you want to combine first? Well, we could. So 2xy and what else? So 2xy's plus 5xy's is 7xy's. All right? What's next? 3y's minus 1y is positive 2y's. Anything else? Minus 7. So the reason I mark them out is to make sure I capture every term. Does that make sense? Mark them out as you use them so you capture every term. The next part is the distributive property. Please ensure that you are drawing your arrows. If I'm distributing, I distribute to the first term inside. So that's going to give me AB. This equals A times B. Then plus A times C. Not a hard property at this point. Okay. Number 6. What do I do if there's a negative in front? Change the signs of each term. What's the sign of 3x? Positive. So I change that sign to negative 3x. 4 is positive. So I change that sign to negative 4. You change the signs inside. Don't stress. Number 7, we're distributing. Negative 2 times x. So negative 2 times x. Then negative 2 times my last term. So negative 2 times negative 4. Then you simplify. Negative 2x, you get negative 2x plus 8. Negative 2x plus 8. Over here, coefficients first, so 2xm, then negative mb. Sorry, I wanted to kind of go through that really quickly. On your graph, we're graphing x equals 2. Find where x equals 2 on the x-axis. Make a point where x equals 2. Go to where x equals 2. Go to the x-axis. Find where x equals 2. Now, is this going to be horizontal or vertical? Vertical. Okay, look at the second one. Find where y equals -2 on the y-axis. If it says y equals 2, find -2. Is this going to be horizontal or vertical? Horizontal. These are horizontal lines. We'll be reviewing this concept over the next couple of days. Flip the page. Now we're ready. All right. So we're doing polynomials. The first thing we're going to go over is how you tell the degree of a polynomial. So right above that, I want you to write this function. 4x cubed minus 15x squared plus x minus 2. Now, the degree of a polynomial, you have to look at the exponent, okay? You have to look at the exponent. You can tell the degree by the biggest x, the x term with the biggest exponent. Biggest x term with the biggest exponent. Sorry, the x term with the biggest exponent. We're not looking at the coefficient. So please make a little note. This is called a coefficient. And this is the exponent. This power, this degree. It's the degree, also the order. But those are the two terms we use. All right? If there's an x and there's a number there, that is the degree of the particular term. So this term is a third degree polynomial or third degree term. Look at the next one. What do you think the degree is? So 2 degrees. Look at the x. What do you think the degree is? If there's no number there, it's 1 degree. When there is no x, what do you think it is? It's called a constant or 0 degrees. The number is called a constant, but the power or degree is 0. Now, look at example 1. I want you to put a circle around the biggest term, the biggest with the highest power, the term with the highest power. So here, term with the highest power is this one. So what do you think the degree of the polynomial is? Third degree. Doesn't matter that there's a second degree term or a constant right there. Just the biggest term. So circle the next one. What's the degree? How easy is this? Should I give you a quiz on this?
Yeah.
Only if he says so. Should I give you guys a quiz on this? Catherine? Not on this? On this? On this? Oh my God. She said no. All right. What do I circle for 10a minus 2? Which one do I circle? 10a or -2? Which one is bigger? 10a. So what's the degree? What's the degree? What? What about the last one? 100y to the 15 in my degree? Easy stuff. Now, things you have to worry about. You need to be able to put these equations in standard form. Standard form always leads with the biggest x term. What's the biggest x term here? What's the biggest x term? 3x to the 4th. So here it's positive, so 3x to the 4th. What's next? So minus x cubed. What's next? Is it going to be positive or negative? So plus x squared, this is standard form. This, we're putting it in standard form. What's next? Do I have an x term? If you do not have an x term, if you do not have a term, you're going to say plus 0 times that term. Plus 0 times x. What's 0 times x? 0. So if it's not there, this is the correct way to write it. What's last? Minus 4. Does that seem pretty easy? Put them in order, I mean. If the term is not there, you have to put 0 times that number, or 0 times the variable. All right, so we're going to put this in order. It says identify the coefficients of each term except the constants in the polynomial. So we're going to have all our x, we're going to put x to the fourth right here, x cubes, x squareds, and x's. We're not going to worry about constants. Let's put our constants out to the side. Let's write constants. All right, look at the first one. Is there an x to the fourth term? Yes. First, x to the fourth? Oh. The first one, there's no x to the fourth term. Could I make one up? Yes. I could write 0 times what? X to the fourth. Okay? But we're writing coefficients only. Only for those that are missing, we're going to write that. All right? What's the next term? X to the third. What's my coefficient? What's the number in front of x cubed? 1. What about x squared? What's the number in front? What's the coefficient? Is there an x term? What will we put for a coefficient? 0. So it'll be 0, put a little note, 0x, 0 times x. Our coefficient is 0, but we include 0 times x. You ready for the next one? What's our coefficient? 10. What about x cubed? What would our coefficient be? 0. Make a little note. It's 0x cubed. What about the x squared term? 0. Good job, guys. What about the x term? 0. My constant? Oh, there's no constant. Yeah, there it is. It's right here. -6. Never mind. Try the last two. Take about a minute. Yes, do the last two. Good job, guys. We're almost there for the lesson. Ready? What do I put here for x to the fourth? 0. X cubed. Coefficient for x squared. For x, constant, -2. Good job. Last one, coefficient for x to the fourth. 0. X cubed. What kind of one? -1. Make sure you got that. For x squared, for x, and constant. What if there's no number there? What does it have to be? 0. Okay? Good job. Good job. All right. Yeah. All right. A polynomial with one term. What do you think mono means? Does it mean 1, 2, or 3? 1. So a monomial is a polynomial. A monomial. So this could be 5x squared y cubed. This is one term. It's one term together. That is a monomial. When I add two terms or subtract two terms, I produce a binomial. A good example, I could say 5x, what do I have over here? X squared, y cubed plus 3. That's a binomial. It's two different terms. They're not like terms. Write that down. Write the example down. Write this down. Write the examples down. So that monomial, five x squared y cubed, binomial. What do you think a trinomial is? Three terms. You can create your own trinomial as long as these are different terms. They cannot be like terms. You cannot do 5 plus 3 plus 2. Those are all like terms. It has to be distinct, different terms. I could do A plus B plus C. That is a trinomial. The terms have to be different. That's all that matters. Now, we're going to, in example 3, identify each polynomial as a monomial, a binomial, or a trinomial, and state its degree. So first of all, how many terms does number 1 have? 3. 3. Now, it's three different terms. So this is 3 terms. What kind of polynomial is this? How many terms does it have? It's trinomial. Does that make sense? Now, what is the degree of this polynomial? How do you know? It's the biggest x term. This is a 3rd degree polynomial. Look at number 2. How many terms? 2. There's x to the 43rd and negative x squared. So if there's 2 terms, what kind of polynomial is this? Binomial. What is the degree? 43. Make sense? So when we write this, make sure you're writing 43. Put a little circle at the top. Look at the next one. How many terms? 1. And the type of polynomial this is? Monomial. So there's 1 term. It's a monomial. What is the degree of this particular? 0. Why is it not 0? There's an x there. When it's x, it's going to be, you're correct, 1 degree. Be careful. Do the last one. How many terms in the last one? 1. What type? Monomial. What is the degree of a constant? 0. Good job, guys. All right. For this portion, we do need calculators. You may not have a calculator. So read through the next part. I want everybody to do this. Get a calculator. Make sure it works. Porto, give me that phone. Give me the phone. All right, first, we're going to write out what's there. First, we're going to write out what's there. Did you follow the directions? It says find the value of negative 3x to the 4th minus x cubed plus 20x plus 3. Did you write it out first? No. Let's do it. What does x equal? 1. If I was going to write it out, if they asked me to write this out for a question for whatever reason, this is how you would do it. Negative 3, parentheses. What am I going to put inside the parentheses? 1 to the 4th minus 1 cubed plus 20 times 1 plus 3. If I was going to write it out, it would look like that. But we're going to do this with our calculator. So pick up your calculator. We're going to use 2 functions on your calculator. we're going to use the numbers, and we're going to use something called store. It's right down here at the bottom, stow. Okay? This is how you can do it with the calculator. What does x equal? So we're going to store a number into what? Into x. Okay? So make sure you're at the home screen. Anybody not at the home screen? You can press clear to clear it out. Press clear. So the stow button, look at the stow button. Look at my finger. It's right here. Okay, but we're not ready to press it. So my first value is 1. Store. You should have 1 and an arrow. What variable are we storing this into? X. Does everybody see X? Okay. Now we're going to write our polynomial just exactly as it is. So first, you have, press enter, and you should see 1 right there. Now, press X for me, please. Press X and press enter. What did you get? Okay, just want to make sure. Now, let's look at our polynomial. You're going to type negative 3x to the 4th. Negative 3x, up arrow, 4. You got to move to the right so that cursor's big. What's the next term? Minus x cubed, good. Thank you. Minus x, up arrow, cubed. Move to the right. What's wrong? It died? All right. Then we have plus 20x plus 3, right? Plus 20x plus 3. Enter. 19. All right, I'm going to show you how to do some quick magic. Write your answer down. Put equals 19. Equals 19. Look at the next one. Is the polynomial the same? Yes or no? Is this a polynomial the same as this polynomial? Yes or no? Are the x values the same?
Yes.
Are the x values the same? Okay. So let's put in our new x value. So we're going to put 2 store x. 2 store x. How do I fix it so I don't have to retype all of that? This is what you press. Look at me. Look at me. Press seconds. Enter. Is that the original? Seconds. Do it again. Seconds. Enter. I messed up a little bit.
Oh, I got it. I got it.
So, yeah, I just hit the wrong button. So, Christine, watch your foot. Did everybody get it? Anybody not get this?
I got it.
Do you know why I showed you how to do that? So you don't have to retype it, right? Save some time. Does that make sense?
Yay.
Do the last one if you haven't done it already. If you're having trouble, I got you. Just let me fix this first.
Negative 13.
So when you're having to do a lot of work, there's multiple ways to do that, but that's just one way. I wanted to show you that just in case you messed up somewhere. You can always just press second enter, and it'll just keep pulling until you get to where you want to be. When I was your age, we programmed these, believe it or not. Negative 13, right? So look at the last one. What do you think x equals? 1. It's inside, right here, it's inside. So right here, inside of there, x equals 1. What do you think this is going to equal? Without even doing it. 19. We already did it. Just another way of saying x equals 1. All right? If it's inside of the radical, the parentheses, it's a 1. Flip the page, guys. Easy stuff today, I'm telling you. All right. Now, so you have learned how to combine like terms in units 1, units 2. You combine like terms also when solving equations. When you're doing addition of polynomials, it's done simply by combining. Don't write like I did. I messed this up so many times today. But combining, that's combing, like terms. Combining like terms. Now this is how we're going to do combining like terms. First, look at the parentheses. Is there a negative in front of here?
No.
Is there a negative in front of here?
No.
Then the parentheses just fall away. So the first step, lose the parentheses. So let's lose it. Rewrite it. X squared minus 6x's plus 5. Secondly, minus 3x squared plus 5x's minus 9. The second step, we're going to group the like terms. We're going to group the like terms. What is your first set of like terms, do you think? X squared and? Let's group them. 1x squared minus 3x squared. Is everybody okay with me putting the 1 in front?
Yeah.
Yes. Okay, what's next? So negative 6x plus 5x. So negative 6x plus 5x. What's last? So plus 5 minus 9. Everything needs a sign. Now, let's go back through. Let's go back through. This is what I want you to do underneath your like terms. I want you to draw a little box here. What's 1 minus 3? Negative 6 plus 5. Negative 1x minus 1x. 5 minus 9. Negative 4. There's your answer. Try the next one. Take away the parentheses first. So rewrite the terms in number 2. You're going to have to do this in some classwork and turn it in at the end of class. And it's different, so you can't cheat off each other. Now, first step, look at the wall. It says lose the parentheses. So you should have negative 5a cubed plus 3a minus 7. What's next? Plus 4a squared minus 3a's plus 7. Next thing, I said rearrange or group the terms. So negative 5a cubed. Is there a term I can group with that number? No. So I'm going to put a little box there so I know not to group it with anything. Okay? Next. What do I want to do next? So 4a squared, is it going to be positive or negative? Plus 4a squared, is there another group term I can group that with? Put a little box. Next, what's next? Plus 3a, and what else? Minus 3a. Put a little box. What's last? So negative 7 plus 7. Carry your signs. Now, what happens to 5a cubed? It just drops. This makes it simpler. You have the correct answer. Negative 5a cubed. What about 4a squared? Yeah. Plus 4a squared. 3a minus 3a? They cancel. Do I have to put 0a? Negative 7 plus 7? Cancels. There's my answer. All right. We add one additional step sometimes. But first, we got to get through the next part, and I think we're done after that. And you have a class to do. All right. So if I multiply, if I have a negative in front, when the parentheses falls away, I just change the sign of what's inside. So here, when the parentheses falls away, how many terms are inside? I should be changing two signs. So the first one, if it's positive right here, what does it become? So negative x cubed, and then positive x squared. I hope that makes it simple. Look at the one below. Two terms inside. The first one is positive, so that becomes negative 2. Second term becomes positive x. Look at the last. How many terms inside? 3. So I go to the first term, it becomes positive x to the 4th. Second term becomes negative x squared. Third term becomes positive 4. I'm doing that with you because this is where people mess up and they just shut down for the rest of you and I. We're not going to do that. All right. What's my first step here when we're combining polynomials? Get rid of the parentheses. Now, star, 4 negatives. Lose it, but change each term inside. So for the first one, I can just rewrite it. It's x squared minus 6x plus 5. But the second one, I have 3 signs to change. My first sign will be positive 3x squared. My second sign is going to be negative 5x. My third sign, positive 9. Next step, step 2, rearrange the terms. We want to group our like terms. So what's our first 2 sets of like terms there? X squared plus 3x squared. X squared, how many x squareds? 1x squared plus 3x squared. And we're just going to go ahead and connect those 2 numbers so I know I'm adding them. What's next? You carry our signs, right? So negative 6x's, mark those out. Negative 6x's minus 5x's. And we connect our signs. Nothing I do is to make your life miserable. It's to make your life easier as you move forward in math. My last 2 terms. Positive 5 plus positive 9. Positive 5 plus positive 9. Let's go ahead and do it. 1 plus 3 is 4. X squared. Negative 6 minus 5 is negative 11 x's. 5 plus 9, 14. I think that we're pretty much done. Do that last problem. There's an example of monomials, binomials, trinomials, blah, blah, blah. You have homework tonight, but you will be doing classwork for me right now. Why? No. Because I'm the best.